Our class today will be on group data. So we're going to look at the measures of central tendency and dispersion using group data. I usually want to take you to grade 3 so that you firstly understand how the pictograms look like. So quickly, you need to understand group data and group data and ungrouped data are different. So whenever we're dealing with numbers that are randomly 3, 8, 7, 2, 2, 7. This is called ungrouped data. Why? Because information is scattered. When information is put in classes, it is called grouped data. So we can have numbers like 1 to 5, 6 to 10, 11 to 15, 16 to 20. This is what we call grouped data. We have numbers like 5, 8, 4, and 3. So I'm going to start with ungrouped data today so that we look at the measures of central tendency and dispersion. So before I go any further, I'll show you two pictograms that I need you to understand. There are two pictures here that I want you to name. This A and B. A is as follows, and B is as follows. Kindly tell me which one is a bar chart and which one is a histogram. Which one is a bar chart and which one is a histogram, A and B?
A is a bar chart.
Is a bar chart. And B, a histogram. Are we all agreeing?
Yes.
Yes, sir.
All right. So we're going to firstly find the mean. Now, how I'll do it is as follows. I'll be doing an example and I'll ask you to do a question of your own, but we move in that order. So to start with is what is called a frequency distribution diagram. So this is how we do the frequency distribution diagram. We start with our cumulative frequency, our midpoint, x, and when we square it, and we have our fx and fx squared. So to start with, how do we find the cumulative frequency? Cumulative means add on. So we start with this 5, we put it here. So 5 plus 8, what do we get? 13. 13 plus 4, what do we get? 17.
17.
17 plus 3, what do we get? 20. Then we also sum up this column to get our 20. So the 20 we get here must always be the same as the 20 we get there. X stands for the midpoint. Height is h. The distance between this number and that number and that number is called your height. In this side, it's the same height. What is our height from here to here? 5. To get the midpoint, we will add the lower and the upper boundary. So 1 plus 5, 6 divided by 2 is 3. 6 plus 10, 16 divided by 2 is 8. Note that even here is a common height of what? 5. So ideally, if you want to simplify your 5, just keep adding a 5 throughout here. 18 plus 5, 18 plus 5, 13. 18 plus 5, 18. Or alternatively, like I said, you add 6 plus 10, 16 divided by 2, 8. 11 plus 15, 26 divided by 2, 16 plus 20, 26 divided by 2, 18. Here we are squaring values of x. So x squared, so 3 times 3, 9. 8 times 8, 16. 18 times 13, what do we get? One what?
Sorry for taking you back. The 8, is it supposed to be squared? 8 squared or
Yeah, 8 squared.
X squared is 64.
Okay, thank you for that. This is 64. Here, eighteen times 18,
324.
24. Okay, then ladies only, you help us find this. So I can call this column 1, column 2, column 3. To find column 1, you simply multiply column 1 times column 2. To find this last column, you multiply column 1 times column 3. So start this row together. So 5 times 3 is 15. Again, 5 times 9 is 45. So really that's true. This line, the ladies together.
Okay, 8 times 8 is 64 on the FX.
So 8 times 8 is 64 on the FX, correct? Then
8 times 64 is 512.
512. Good. Okay. And the gents slide. How are we going to get these figures here? We're going to get figure A, B, C, and D. So A, arrow, how do we get this figure? Chippy, how do we get A?
Hi, Collins. Apologies, I'm working, but the how we get the A is by multiplying 4 multiplied by the X figure, which is 13. It will give us the answer there. Then when we get the frequency also multiplied by the X squared is what will give us the B.
All right. Thank you. So what are the actual figures, anyone with the calculator? So 4 times 13, what do we get?
52.
52, correct. And 4 times 169, what do we get?
678. I mean 676.
676. Okay, and then here, C, what do we get on C? Ladies, C and D. 3 times what? 18, and 3 times 324. So what is 3 times 18?
54.
54. And 3 times 324, what do we get?
972.
972.
974. So you only concentrate on numbers with the column with an F. So let's total up here. This will be summation of x, and here this is summation of x squared. Let's total up here. What are we getting? This one has a hand.
Yeah, sorry to take you back. The column for X, that's C2, the one you've named C2. How are we getting that?
C2. How are we getting C2? So we're adding the lower bound as the upper bound divided by 2. So 1 plus 5 is 6 divided by 2
Oh, so you're
is 3.
finding that's the midpoint for the class.
Midpoint, yes. The lower
Oh,
bound plus
okay.
upper bound divided by 2. We mentioned 2 ways.
Okay, I think I just missed it.
So 6 plus 10, 16 divided by 2, 8. Or since the height is 5, just keep adding 5 here. So 5 plus 3 is 8. 8 plus 3, 13. 13 plus 5 is 18. So keep adding a 5 throughout. It's another way. All right, those that we're totaling up, what total we get here?
For fx, 185.
185. Okay, then fx squared.
185.
Then here,
2,205.
2205.
2,205.
So this is a figure, right? Okay, so now go to calculating the measures of central tendency and dispersion. So we have summation of F20, 185, 2205. So summation of F was what? 20. Summation of Fx was what? 185. The summation of Fx squared was 2205. How do we find the mean? Mean on group data is given by the symbol x bar. This mean is simply found by summation of fx over summation of f. Let's substitute. What is summation of fx from the data that we have? $185. And our fx, summation of f,
20.
20. When you divide, what we get as our mean? What we get is our
9.25.
pardon?
9.25. 9.25.
9.25. Great. And symbol is called the variance. The variance is given by summation of fx squared, summation of fx whole squared divided by summation of f over summation of f minus 1. This is for sample variance. The minus 1 comes out if we're dealing with a population variance. So this is what we call our variance. So if we substitute, note that these two figures are different. Fx squared without brackets is a bigger number. It's 2205. Okay. Fx to the power 2 is 185 to the power 2 divided by what? Our f is 20. Everything over 20 minus 1. So we're starting from here. You always start from here. What is 185 squared over 20?
1,711.25. 1711.25.
1711.25. So what is 2205 minus 1711.25? 20 minus 1, at least we know this one is 19. We do them with one way. So 2205 minus that one, what are you getting?
493.75.
493.75. When you divide this, what are you getting?
25.9868.
25.98. So this is called our variance. This is called our variance. So relationship between variance and standard deviation is that our standard deviation is the square root of the variance. So when we square root our variance, we call it standard deviation. So what's the square root of 25.95? 25.98. What is the square root? 5 point what?
5.09.
5.09.
5.098.
All right, quickly, what have we said? The mean is the average. Summation of x over f, we divide 195 over 20. This is our mean. Variance is dispersion from our expected mean. How are we deviating from our mean? It's fx squared minus fx all squared over ef over ef. So this in some books is denoted by the letter n. It's the same thing. The n is the total frequency. So 2205 minus 85 squared over 20, we found our answer is 25.98. When we square root that answer, we get 5.098. So this is what we call a standard deviation. So our CV, which is coefficient of variation, is simply standard deviation over our mean times 100. Standard deviation over the mean times 100. So what is our standard deviation? 5.098. And what is our mean? 9.5. When we apply this by 100, what do we get?
55.11.
55.114. 114%. So this is giving you the percentage by which the mean is deviating from our expected value. So 55.114. This is how we find our coefficient of variation. Then you'll be asked to draw a histogram. In this case, you notice one thing. This number histogram must have a certain projection. 1 to 5, you start from 5 to 10, and you start from 10 to that number. The number that you're ending with must be your starting number. The number you're ending with must be your starting number. If that is not the case, we use a correction term by subtracting a 0.5 and adding a 0.5 on the upper boundary. So this is what we do in statistics. So do the same to adjust our figures there. So what are we going to have? If we adjust that, we're going to have the following. So here we're going to have 0.5 to 5.5. We subtracted 0.5 here and we added a 0.5 there. You only do that when you notice that these numbers are not the same, the diagonals. And here we subtract what? 0.5 from there, what we get? 5.5. And here we're going to have 10.5. In fact, the upper boundaries are easy. Just put a 0.5, 0.5, 0.5 there. This is what? 15.5. This is what? 20.5. Let's bring these numbers down. Our 10.5 will come here. This number comes down. Our 15.5 come here. Because when you subtract a 0.5 from there, it will be 15.5. What does this one help us do? It helps us draw our histogram. So somebody was asking, what is the X standing for? It stands for the midpoint, where F stands for the frequency. So now we want to draw this so-called. We usually divide from there, and we just use an L or a 7. These numbers I'll start from 0.5, 5.5, 10.5, 15.5, 20.5. And here frequency, you can use your own 2, 4, 6, 8, 10, 12, 15. Use your own projection as long as it makes sense. So here we have 0.5 and 5.5 and 10.5, then 15.5, then 20.5. Starting from 0, here we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. We pick the highest number, make sure it's covered here, the highest number. So our first class is from 0.5 to 5.5. The height is, or the frequency is what? 5. So this one will go up to 5 here. Then 5.5 to 10.5, the frequency is 8. It's connecting here, 8. Then 10.5 to 15.5, the frequency is 4. So we go to 4 there. 15.5 to 20.5, the frequency is 3. So 3 is somewhere there. So here we started from 5, 8, 4, and what? 3. So our frequency and our class. This is how we draw our histogram. So you should also put your title and you're done.
Hi, Collins.
Yes, please.
You said, why do we put those double marks on the horizontal line on the x-axis?
Because the distance from here to here is not, you're saying you're not starting from 0. So sometimes you can even write 11 here. It's like you're cutting it. Okay, it's okay. I just joined that one there. Unless you are using a uniform scale from 0 to what? 5.5, 10.5, it's uniform. So usually cut this to just show that from here to here it's not uniform. Is that clear?
Very clear, thanks.
All right.
I also have a question. On the intervals here, where we're subtracting 0.5 and adding 0.5, there's something that you said that you know I missed it. You said if the numbers.
If the numbers are already in this order, 10.5, 15.5, 15 to 20. There's no need for adjusting because this is already in bar chart form, because ideally 10, oh sorry, this is 10. So this, the ending number is a beginning number. And the ending number is a beginning number there. If these are the same, you don't need to subtract 0.5. So in this case, these ones are not, it's a gap of 1. So if you're going to do them as they are, it will come out as a bar chart to look like this, like that, because there's a 1 in between. that clear? Okay. Then we go to ungroup data. Sometimes you'll be given information as follows. 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. Okay. We have 0, 3, 0, 5, 0, 9, 11, 12, 12, 12, 22, 24, 24, 28, 29, 30, 33, 35, and 40. So you are told to first draw what is called a stem and leaf diagram. So a stem and leaf diagram is drawn as follows. The numbers that start with 0 are called the stem. The numbers that we have numbers that start with 0, we have numbers that start with 1, numbers that start with 2, numbers that start with 3, and numbers that start with 4. Their order. So numbers that start with 0, we have 0, 3, so 0, 3. And 0, 5, to write the 0 because the stem is already there. So we put 0, 5, and 0, 9. 0, 9. On the ones, what numbers we have on the ones? We have 1, 2, what? 1, 2 again, 1, 2, then
11. We missed the 11 somewhere.
oh, we left 11 somewhere, right? We're supposed to start with what?
1.
1, 1. 1, 1, 1, 2, 1, 2, 2. Next numbers. 2 what? 2, 2, then 2, 4, then 2, 4, then
4 again.
2, 8, then 2, 9. On the threes, we have what? 3, 0, 3, 3, 3, 5. On the fours, we have 4, 0. So this is what we call the stem and leaf diagram. Now, stem and leaf diagram summarizes and reorders your ungroup data. So they'll ask you to find the range. What is the range? Anyone? How to find the range? Highest
The
number.
difference between the largest and the smallest number.
Yes.
The data set.
Biggest number and the smallest number. What is the maximum number? 40. And the smallest number? 0.3. So what we get as our range? 37. Mode is a number that appears the most. Which number appears the most here? Which number is this?
12.
Is it 2 or 12? What number is this which is appearing the most?
2.
12, yes.
2.
So mode is the most frequent. And we go to the lower quartile. Lower quartile is called Q1. The formula for Q1 is a quarter of n plus 1. Now this should give you the position not the actual value. So here we have what? 16. 16 plus 1 is 17. What is a quarter of 17? 4.25. So we round off to the nearest whole number. What is 4.25? The fourth number. So let's count from here the fourth number. So let's go through again. Q1 is called the lower quartile. Okay? And quartiles are simply quarters. So Q1 we get quarter. Q2 is like the median. We get half. Q3 is the upper quartile. We get what? 3 quarters. 3/4. We're starting with the lower quartile, which is Q1. So our n, when you count all these, 1, 2, 3, 4, 5, 6, our n is what? 16. N stands for the number of elements you have. So we add 1 to this, so 17. A quarter of 17 is 4.25. So if you have numbers like 4.25, you pick the nearest, or the whole number is 4. For 4.75, we pick the whole number, which is 5. Unless we have a 4.5 in packet, we pick the fourth number and the fifth number, and divide by 2. So here we found 4.25. So the fourth number here we count 1, 2, 3, 4. So what number is this? $11, not 1. So this number is 11 because the stem starts with the 1. So if we had numbers like 120, here we put 12 and 0. If we had 102, we put 10 and 2. The last number is what comes the leaf. So Q2 is also called the median. So half of n plus 1. So n plus 1 is 17. Half of 17, 8.5. Can somebody tell me, now that we found 8.5, which numbers are we going to look for? This is a 0.5 there. Eighth number plus what?
8 term and the ninth.
Then the ninth number
And the ninth number, correct. Divided by what?
by 2.
So let's count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what two numbers are these? The 2 plus what?
24.
24 divided by 2. So what do we get?
23.
23. So 23, the second quarter is also called what? Median. Who wants to lead us in the upper quartile or the third quartile? Q3. How do you find Q3?
Q3 is the 3/4 of n plus 1.
Now n plus 1 is 17. What is 3/4 of 17?
Those with calculators can help me with the number.
12.75.
Pardon?
12.75. So what do we do with the 12.75?
12.75. So, the 12.75 is we get the 13th number
13th number, correct?
as a position.
So we
Then
count.
count 1, 2, 3, 4, 5, 6, 7, 8, 9,
10, 11, 12, 13. So what number is that?
30.
30.
So Q3 is 30. Okay. There's a question there. There's a hand. Yes. Marker.
So you're saying if the term we're looking for, if it's exactly at 0.5, That's when we add and find the average. But if
Yes.
it's above 5, we just go to the next one. Okay.
Only at 0.5, that's when you get the average. If it's above 0.5, you get the nearest upper. If it's below 0.5, the nearest lower. So if you found 12.5, we pick the 12th. Verified? Right. Somebody told me difference between the third quarter, Q3, the first quarter, Q1. What do we call that?
Interquartile range.
Excellent. So the interquartile range. Interquartile range is the range of the quarters. So the upper quarter we found as what? 8. The lower quarter we found as 11. So 30 minus 11, we get 19. Okay, then if we divide our interquartile range by 2, or we multiply it by half, call this the, what do we call this?
Semi-interquartile range.
Semi-quartile deviation, correct. Anything half is called semi. Half of 19, get what? 9.5. This is called our semi-quartile range or semi-quartile deviation. How about if we multiply 1.5 times the interquartile range? What do we call that? 1.5 times the interquartile range. Call that the correction term. XCT, correction term. 1.5 times 9 times what? 19. What do we get? 1.5 times 19. What do we get that?
28.5.
20?
28.5.
28.5. Correct. Now, there's a special box or plot that we call a box whisker plot. It has 5 key elements. Number 1, we need to draw the lower value of x and the highest value of x. So x mean and x max. So what does our x mean? So you need to find the x mean, the Q1, the Q2, the Q3, and the x max. So what is our x mean? When we go here, what was the lowest value? 0.3, and the highest value was 40. So this is 3, and we have 40 here. And the Q1, 11, 23, and 30. 11, 23, and 30. Then using the correction term, the upper bound you add, the lower bound you subtract. When you add this one, 30 plus 28.5, we're going to get 58.5. Then we subtract 11 minus 28.5, what do we get? Negative 18.5. Now, this helps us identify the outliers, which numbers are outside of range, numbers are offside. So the 3 is within range, the 40 is within range. We can simply say we have no outlier. Simply say outliers are not what? Existent. So this is how we draw the box whisker plot. Right. Still on ungrouped data, you could be given figures like 2, 3, 3, 4. You square them here. 4, 9, 9, 16. The total here is called the summation of x. The total here is summation of x squared. What do we get here? What do we get here? 38. So who can tell me how to find the mean? Mean for one group data is summation of x over what? By n. What is the summation of x? The summation of x here is what? 12.
12.
Divided by n. How many elements we have here as our n?
4.
4. 12 over 4, we get a what? A 3.
3.
This symbol stands for the what?
Variance.
Variance. What's the formula for the variance? Somebody tell me from the head.
Is equal to x, the sum of x minus x squared over n, yeah, n minus 1.
So here what we have? 38.
38
And here 4 squared over what?
144
Over 4, everything over 4 minus 1. So here 144 over 4, what do we get? 36. It. So 36 from 38 is 2. 4 minus 1 is 3. So 2 over 3, we get 0.67. How do we get the standard deviation?
It's the square root of the variance.
Yes, standard deviation is simply square root of the variance. So our variance is 0.67. So what is the square root? So calculating mean, simply total up this. 12. How many are they? 4. So 12 divided by 4, the mean, which is what? 3. That's how we found this 3. And we square these numbers. Don't square this figure, no, we square them individually. 8. And find the variance, summation of x squared minus summation of x over 2 n minus 1. This one is just n, population variance. Symbol for population is sigma, but if you have n minus 1, it's sample variance. So 8 minus 12 squared over 4. So 12 squared over 4 is 36. 4 minus 1 is 3. So 38 minus 36 is 2. 4 minus 1 is 3. And divide that, 0.67. This is called our variance. To square root it, we get 0. What?
0.8182 or 818.
0.8 what? H2. Finally, to find the coefficient of variation, is simply the standard deviation over a mean. We multiply this by 100. So 0.82 divided by what? Mean, which is 3. 0.82 divided by the mean. What do we get as a percentage?
27.3. 27.3%.
Not very audible. 0.82 divided by 3 times 100.
27.3.
7.3%. Right. How do we find the median? Remember the median? Half of n plus 1. Median, half of n plus 1. What do we get?
Two 2.5.
So what do you do to the 2.5?
So that's the position. So we go to the
What position?
third position.
Second position plus third position divided by 2 because it's a 0.5. So 3 and 3, if the number is the same, just pick it up. 3 plus 3 is 6 divided by 2, 2, 3. So our median will be what? 3. So that's how we find the median. I needed that because I simply need to m is up, calculate what is called the coefficient of skewness. It's given by 3 in minus median over what? Over our standard deviation. That's the standard formula. Our mean was 3, our median was 3. Coincidentally, our standard deviation is 0.2. So we're getting a 0. So this is skewness. Now skewness helps you find distribution. If it's normally distributed, your skewness is 0. 50-50. Here it's 50, and here it's 50. It's even. Right? You get a positive answer, means you're positively skewed. Means maybe above 50%. If you have a skewness or distribution where many people passed, it means this is a positively skewed distribution. If you have a distribution where many people failed, this is a what? A negatively skewed distribution. Say negatively skewed. When you get a 0, we say it is normally distributed. It's normal. So this is we end for grouped data and grouped data. This is where we end for grouped data and grouped data. We'll continue in the evening. I'll leave you with some bits of work as usual. I need you to find this one here. You find the mode, send it on the groups so that you can try the works. I'll just send you 2 questions, so you will try them. That will require of that work. Thank you so much. I'll also share the recording. Unless there are any burning questions at this point. All right.